thanks for coming to this. I'm going to talk a little bit about Beyond the Birdhouse. So I'm going to talk about sort of how I structure a lesson. If you were in my previous section on managing the CS50 classroom, some of this might be repeat. So I'm totally fine if you stay for a portion of it and decide, oh, you know, I've already seen this. There are a lot of other good things too. But, and please feel free to stop me at any point if you have questions. Just raise your hand or just interrupt me. And I'm happy to stop and talk. I want this to kind of be something that is useful for you. So I want to talk a little bit about designing computer science activities to support all learners, but I want to try to widen sort of how we define computer science and what we think about when we think about computer science. So I want us to think about this YouTube video in terms of how does this represent computer science. So this is a video, this is a commercial that Burger King did.
There was?
With net neutrality, you know, some people, for what it's worth, just, you know?
I don't know exactly what it is.
Got a number one. Hey, how you doing?
Do you know what number 98, what's going on with it?
Number 98, you got the Whopper?
Yeah.
So you got the slow access Whopper pass?
Wait.
It's on the menu right there with the fast, medium, and slow.
Slow MBPS, fast MBPS, or hyper fast MBPS. MBPS, of course, standing for making burgers per second.
So if we want a Whopper now, we have to pay $26?
Well, that's how you get it fast. That's the highest priority.
This is like a lane system?
It's gonna be like 15, yeah, fast lane, slow lane. So like maybe like 15, 20 minutes.
What are you talking about?
Burger King Corporation believes that they can sell more and make more money selling like chicken sandwiches and chicken fries, so now they're slowing down the access to the Whopper.
Were you given an option of a chicken sandwich or?
Yeah, I don't want a chicken sandwich, Robert. I want a Whopper.
Do you have any Whoppers ready that aren't?
Yeah.
The sandwich is ready. I'm just not allowed to actually get it to you.
What? You can't give me the sandwich? It's ready, but you can't give it to me?
Whopper neutrality was repealed. They voted on it.
Whopper what? This doesn't make any sense.
Fortunately, I have no other choice.
Oh my God, this is the worst thing I've ever heard of.
See, like he got the fast, and now he's getting his.
Are you kidding me? You paid $26 for a Whopper?
Yeah, he ordered it. Now he's a higher priority, so.
Come on, guys, like, I want a burger, man.
If you'd like,
This is a bad dream right now. I just want a burger, brother, a burger.
You want
I
to pay
feel like I'm going to say this is crazy.
Here's what I'll do. You have the bag, and I can put it in the bag in 42 seconds. Hold on, 10 seconds. We don't make the rules.
You just enforce these ridiculous rules?
Fortunately, we have to.
Guys, come on.
I felt like I was being taken advantage of in a sense. Just as a customer coming in to get their food, it felt like a power move.
They already changed the policies overnight or whatever.
I didn't think that ordering a Whopper would really open my eyes up to net neutrality.
The Whopper actually taught me about net neutrality. It's stupid, but true.
All right, how is that computer science? What are your thoughts? Is anyone familiar with what net neutrality was in the United States? So net neutrality was a policy where internet service providers could charge more for faster access to certain sites. So if they wanted to drive traffic to, for instance, streaming services that they owned, they could make access to those streaming sites a lot faster for less money, but traffic to their competitors, they could charge more money or slow the access down dramatically. And so this was a proposal that was to be voted on, but nobody really understood very much about it. And so it passed kind of overnight, and people were sort of shocked and surprised by it. And so this was a commercial to kind of illustrate with burgers this idea that you have a burger, but not everyone is entitled to the same access to that burger. People who are willing to pay more money get their burgers sooner than other people. And so it was kind of a funny illustration of maybe a not so funny situation involving the internet. So yeah, what does that have to do with computer science when we think about computer science? So we should ensure equal opportunities to access to resources. Yeah, that's kind of an interesting philosophical idea, you know, and it's a good discussion to have. Access, if you do have equal access, it's easy to take that for granted. It's easy to just assume that we're always going to, you know, that equal access does not have to be protected, right? But this is something that affects anybody who uses the internet, at least in the United States. There are probably laws about it here. But the internet, how the internet works, and policies around the internet, and policies around privacy on the internet, that's computer science just as much as coding a for loop or a while loop. And so it's an important message, I think, that programming it's not just about programming. Computer science is really about a lot of things. It's about a much larger section of internet and technology. So one of the things that one of our key concepts in the United States in terms of some of the standards that we look at is that every student will know how to live productively and safely in a technology-dominated world. So that means understanding these essential features of digital technologies, why and how those digital technologies work, and how to communicate and create using those technologies. So that is a core statement for the New York State standards, for example. And the standards are broken out into these 5 areas, and these are similar to other frameworks as well. But notice we typically will focus on the impacts of computing, issues of cybersecurity, digital literacy, networks and system design, and computational thinking. So when we teach computer science, it's not just about computational thinking. It's also about society, it's about ethics, accessibility, it's about how does the internet work, how do packets get transferred over the internet, also about digital citizenship. There's kind of I think a big question right now. Kids who are using ChatGPT to help sort of help them with assignments or help do research. How do you cite that, right? How do we come up with ways to cite where we used AI and where the ideas were completely original? I was trying to have a little fun with that when I designed the keynote for you folks. This idea of, of course, ChatGPT doesn't actually talk to you. I kind of made that part up. But this idea of an AI that aggressively tries to take credit for the work that I'm doing, I thought was kind of funny. And I also found it made me a bit defensive about the work that I put into that. So when Linda asked me to create this keynote, I cared very deeply about creating a keynote. But I used ChatGPT and I used DALL-E to help create large portions of that keynote. So that chart about teaching and how teaching has changed in the past few years, I actually asked ChatGPT create a chart about how teaching has changed in the last 50 years. And then I rephrased some of what it said, but that chart came originally from ChatGPT content. So I created a bibliography that's kind of annotated where everywhere ChatGPT helped, I made a note of it in that bibliography. And I think that that's going to be more and more important. When we give kids, we want to give our kids activities and projects that they care deeply about, like doing a keynote. I wouldn't have wanted to give ChatGPT the ability to write that talk. I cared too much about it. But I certainly would let it help. And I documented where it helped. And I think that could be a framework going forward let's give our kids projects that they care enough about that they wouldn't want to just hand it off to an AI to do entirely and take credit for. They should be proud of the work that they're doing. They should have a way to take ownership and pride in the work that they themselves did, and they should have a way to cite responsibly any research or AI tools that they've used to kind of help them along the way. So here are all of these subconcepts of these areas that we kind of try to teach. If we teach a full computer science curriculum, it really should cover all of those things. And so what we started with in our school is we said, okay, here's what we're teaching. Here's what we're teaching in terms of computer science, and we wanted to map that curriculum to the standards. And then we wanted to say, let's do a gap analysis and figure out where are those things that we aren't covering. And then let's look to build new content to kind of fill in those gaps, fill in the areas that we still needed to fill. And so one of the things that we didn't really teach very much about was this idea of how do you design a new computing innovation. So computing innovations, teaching about computing innovations, that's part of the AP framework. It's part of the New York State framework. It's part of the CSTA standards. This whole idea of how do you design and create new materials, new technology tools. That's part of the standards. That's part of computer science. And so we actually approach it from the process of design thinking. So how do we design something new? And we think about code in that code allows you to build the things that you want to see in the world. That's the context behind the tool. The tool is code. The context is what kinds of things would make the world better? And then how do we create those tools? And so we want to build something that matters. And when we design things that matter, we're focusing on the users. As developers, we're not just building apps. We want to build apps that other people want to actually use. And so if we're designing an app, the goal is to create an app that everybody would want to have on their phone. So one challenge, in my class, I'm challenging my kids all the time to try to build bridges between individuals. And so again, we're focused on building things that matter. And so here are some examples of things that my kids have built with Swift and Xcode. So this is an app. Actually, this was a different student, not one of my own students, but she was on the news. She actually, she found that she experienced being bullied in high school. And she found that one of the hardest decisions that high schoolers have to make is who to sit with at lunch, and it causes a great amount of stress. Where are they going to be? Where are they going to, kids just dread being that kid who just eats by themselves all the time. And so this idea sprung out of, she made an app called Sit With Us. And the idea with Sit With Us is if you're willing to have other people sit with you at your lunch table, you can kind of put it on the app, and then the app will allow, it'll be a matchmaker, so that if you're looking for someone to sit with at lunch in the next 20, 30 minutes, you can use the app and get matched up with a place where when you go there, no one's going to say you can't sit here. So that was a great problem, and it's not a problem that I would have thought of at all as an adult. I never worry about who I sit with at lunch, but it's a big deal for kids, and it took a kid to recognize that and then build that app. So we take kids through this process of planning and talking with each other, and then prototyping on paper what kinds of things that they would do. And then we actually have them test it out and evaluate it with other people. And so, I had one kid who, he basically was looking for a project. So I matched him up with a parent at our school. And she was a teacher, but she was also a parent of a child with autism. And she had designed ways to teach her children how to count with numbers. She designed this system, but she had no way to share it outside of her family. So she worked with him, and Lance built this app for her that it works on an iPad, and it allows you to learn place values and learn how to count in ways that that work for children with autism. And what was really neat about this was when they started, she didn't know anything about app design or building an app or programming an app. And Lance didn't know anything about autism. But by working together, they both ended up learning a whole lot more. And so I think a lot of the time as teachers, we can just make those connections. If you make connections between people who have a problem or have something to offer and students who are interested and motivated to create something that helps somebody else, that can be a very powerful connection to make. Natalie Hampton is the one that kind of came up with the Sit With Us app, and this is what she says. She thinks that if you make small incremental changes in the overall dynamic of a school community, those small changes can bring about change on a larger scale. That's a lot of wisdom, I think, for a 16-year-old to have. It's remarkable. But, you know, these are the opportunities we give our kids when we allow them to go beyond the birdhouse and create this independent project. And so when I say beyond the birdhouse, here's what I mean. So birdhouse activities are guided activities. Unplugged activities really are where you would introduce a skill. And often I'll do that using an activity or a hands-on activity. Usually it's away from a computer. So it might be a paper and pencil activity, or it might be what I'm going to ask you to do in a moment is to everybody stand up. We'll do an unplugged activity. And then I move them to a birdhouse or guided activity, and then finally some independent project that's meaningful, that reinforces those same skills. So let's go to this unplugged activity. The idea with unplugged is it's a really effective way to introduce new computer science concepts, and it happens off the computer. So what I'm going to have everybody do, if you wouldn't mind, you're going to have to move around a little bit. You're going to have to walk around. So everybody stand up. And I'll play also here. Okay. Thank you for humoring me. So when I say go, here's what we're going to do. So we've all stood up. You're going to assign yourself the number 1. So everybody here is 1. And then what you're going to do is when I say go, you're going to go find a party. You're going to pair off with that person, and you're going to add your 2 numbers together. So if I'm a 1 and the other person's a 1, we're both going to be 2. But if I'm a 1 and you're 2, we're both going to be 3. We'll be the sum of 1 and 2. So the numbers might be different, but you're going to add them together, and then one of us will sit down. Okay? And then we're going to repeat steps 2 and 3 until only one person is left standing in the room. Everybody got it? Okay? Okay, so let me go over that again. So everybody is number 1. When I say go, you're going to just go to somebody next to you, and you're going to add your 2 numbers together. Find out what number they have. You know what your number is. Add those 2 numbers together, and that sum becomes your new number for both of you. But then one of you needs to sit down. You can figure out who sits down. Some people rock, paper, scissors, or just whoever sits down first. Up to you, okay? All right, let's try it out. Let's go. All right, so I'm 1, and you're 1. So now 2. We're both 2. So why don't you, I'll sit down. You go and meet with someone else. You're 2. Okay, we got a few people standing up still, so keep pairing up. Okay, are you guys still playing? We have one person standing here, and are you still playing? Okay, let's see. Great, we have 4 people left. You're still standing? Oh, you're both sitting. Okay. All right. And then a bunch of people left, which was interesting, so we'll figure out how this works. All right. Okay. What are the 2 numbers?
14.
14, and what's your number? 4. So 14 and 4 is 18. Okay. So what's the significance of that number? What should the number be?
Odd.
Maybe an odd number?
Odd number.
Okay. What would be the significance of the number if we do this? Anybody know what that number? Anyone want to guess? What would that number represent in this room? Number of people in the room. Yeah. Now it seems to me there's probably more than 18 people here. So that's good because it gives us a chance to debug the process. So here's where I'll introduce that vocabulary where debugging is what could have gone wrong? What could have gone wrong in the process? Because 18 is smaller than it should be probably. What happened? Yeah, so maybe making a mistake with adding the numbers. That's one possibility. A number of people took the opportunity to flee out the door. As soon as this activity started, they were leaving. And so that might be part of it too, right? What else? What else?
Instruction understanding. Understanding the instructions?
Maybe, yeah, maybe the instructions were, yeah, so people might have misinterpreted the instructions, or maybe 2 people sat down, possibly, right? But those are all opportunities for us to debug the process. And if we were to do this again, we're not going to do this again. But if we did do this again, you probably, having gone through it once, would have a more streamlined process. But ideally, ultimately, you do end up with the number of people in the room. Because everybody, right, after the first comparison takes place, half the people in the room are seated, right? So, and then we have the half that remain. The next time that comparison happens, half of that group sits down. And so the number of people standing gets smaller very quickly. And that's computer science. So here's some of the math behind it, right? If it takes 10 seconds to find out what's your number, let's add them, and then we rock, paper, scissors, whatever we do, and then somebody sits down. That takes 10 seconds, right? Then if we only have maybe 24 people in the room, right? If we have 24 people in the room, it's going to take almost a minute. Because after the first comparison, we have 12, then we have 6 people, then we have 3 people, then we have 2 people, and then 1. So that would be 5 sequential comparisons. Is about 50 seconds. But if we counted off in the room and said, you're in 1, 2, 3, 4, 5, 6. If you all counted off individually, it would probably be faster, right? If we just went one by one. But look what happens when we go to 100 people. With 100 people in this room, more people than we have now, if we had 100 people, after one comparison you have 50 people, then 25, and then 12, and then 6, and then 3, then 2, and then 1. So that's 7 comparisons. It's 70 seconds. And 70 seconds is probably faster than if we counted off one by one for 100. So this is an example of an algorithm that gets more efficient the larger the number of people. Because look what happens. If we go from 100 people to 200 people, right? If we go to 200 people, that's just one extra comparison. If we double the number of people in the room from 100 to 200, you're only adding 10 seconds to the entire calculation, right? With 500 people, if you do the math, it's 90 seconds. I've actually done this in an auditorium with 500 people. And it's very fast, and it's surprisingly accurate. And why is that? Well, all of these comparisons are happening simultaneously. So this is an opportunity to talk with students about parallel processing versus sequential processing. Sequential is if we're counting off 1, 2, 3, 4, 5, 6, 7. But parallel means we're doing many operations simultaneously. And with 1,000 people, it's just 10 comparisons. It's just 100 seconds. So the core concept here is some algorithms become much more efficient the larger the set of data you're operating on. And that's a core idea in computer science, but we can get to this idea, we can introduce this idea without a computer, just by playing a game. So that's the idea of an unplugged activity. So some of the advantages of unplugged activities, they're free. You don't need a computer. They're very effective at introducing new concepts. I did this in my high school auditorium with 300 kids as a way of getting everybody to do computer science. And after we did that, I said, look, some of you might be thinking of taking CS50 next year. You've all done computer science now because we've done this activity. You've all had an introduction to it. That's what computer science is. And that's part of the way that we kind of get more interest in kids who are taking computer science. So you can get more unplugged activities here at csunplugged.org. So the birdhouse activity, it really goes back to when we used to have wood classes, and we teach kids tools. And every kid makes a birdhouse. And that's often the introductory activity, is you're going to make a birdhouse. And every kid makes the same birdhouse. And the advantage is the birdhouses all look the same. See, this is great when you're trying to train cooks, right? You want to train a kid to be a cook, you give him a recipe. Here's how you build a birdhouse. But don't stop there. Don't stop after the birdhouse activity. You want to go beyond that. Because birdhouse activities are very high on new skills, because everything they're learning is new. But they're very low on creativity. And there's not really many ways that you can differentiate a birdhouse, right? You can maybe paint them a different color, but it's still basically a birdhouse. So we want to give kids opportunities to do independent projects after the birdhouse activity. And the independent projects are low on new skills because I'm not asking you to learn new skills, but they're very high on creativity because I want you to think creatively and build a project that you care about. Some schools skip the birdhouse. Some schools say, hey, we're going to learn web development, so everybody figure out what kind of web page you want to build. Here's the internet. Go figure it out. And kids can do that, but how do you assess that? How do you assess what the kids actually know? Everybody's learning different things. Like you don't have a baseline of skills. So, you know, it's kind of hard. I listened to a podcast with a food writer that I really admire. His name is J. Kenji Lopez Alt, and he writes for the New York Times. And he has an 8-year-old daughter. And he's trying to teach his 8-year-old daughter how to be a chef like he is. And the interviewer asked him, how do you get your kids to learn how to cook with you? And he said, well, it's really easy. I ask her opinion, and then I honor her opinion. So while we're cooking together, I'll say, here, taste this. Does it need more salt? And whatever she says, I honor that. If she says, yeah, we should add more salt, then I'll put in more salt. Even if I disagree, because I'm honoring her opinion. I'm letting her know that she has a voice in the process and that her voice is important. But I don't ask her, here, taste this, what do you think we should add? I don't make it a completely open-ended question, because if I ask my 8-year-old daughter, what should we add, she's going to say chocolate syrup. Like every time, add chocolate, right? And so he gives her some structure. Should we add more salt? And then he honors her opinion. And I think that's the difference. We want to give our kids structure, but we want to give them some choice within that structure. We want to teach them the skills of how to be a cook, but we want to encourage them, ultimately, we want them to aspire to be chefs, to do something extraordinary with the skills that they've come up with. That's what the independent project is. So in our curriculum, we actually are learning Swift. So we're learning how to create apps for iPhone and iPad using Swift. And we use a textbook. I think of it like a cookbook, because here's an example of, they'll say, here's a new project. You're going to create an app that displays a photo. And it tells them specifically, like step by step, what to do. That's a birdhouse activity. And that's important. They start there. But then we have them come up with a prototype for an app that solves a problem or serves a purpose. So here's the app that one student came up with. The challenge was help a new student at school. And what they had to do was they had to go about figuring out, well, what does a new student at school have to deal with? And so they started asking, who here has been a new student? And then they asked them, what were things that were difficult for you? And one of the things they realized was that when you're a new student, a lot of the time, you feel this sense of panic. Like, I'm supposed to be somewhere and I don't know where I'm supposed to be right now. I would have that here, but I have Linda to help me. I don't know where the room is, and I say, oh, Linda, help me out. But they created an app that does that called Where Should I Be? And the entire app, the only interface is a button. And you press the button, and it tells you where you should be right now because it has access to your schedule, and it knows a map of the school. And so immediately, anytime you're anxious about where should I be, you press the button, and it'll look on your schedule, and it'll say, here's where you are, because it knows where you currently are on the map. And you're going to walk and go to the right building. And so that was their app they came up with. Now, this independent project doesn't have to actually be coded. In the beginning of the year, my kids don't know how to create apps yet. But they can come up with prototypes to solve problems. And so I'm getting kids constantly to experiment with coming up with these prototypes. And we play this card game called Mission Feature Feature, which is a fun card game. You have one mission and you have two features, and then you have to come up with, brainstorm an app that kind of solves that mission and has those two features on it. So, if I just pull up, one mission is order food, and one random feature is speaker and GPS. So I'm going to have to brainstorm, what is an app that allows me to order food that uses a speaker and a GPS? So GPS lets you know where you currently are. So maybe when I use the app, it'll pop up a number of food places that are near me, and when my order is ready, it'll announce the order over the speaker. So that's my prototype app. And so you never know what two features you're going to get and what the mission is, but the card game is a great way to go about figuring this out. We'll have to put a link. You can buy this actually. It's missionfeaturefeature.org. So the name of the game is missionfeaturefeature.org. And one deck of cards you can use with an entire class of kids. And we use this all the time. My kids do all kinds of prototyping. They're getting a lot better at it. Yeah, you had a question.
Yes, I wanted to ask, how do the kids find the projects that they want to work with? You brought this example, and how did they come up with this project, or who came up with this project?
Well, typically kids need a little bit of guidance, so I'll give them a challenge. In this case, it was help a new student at school. Okay. And then they had to brainstorm all different ways that they could design an app to help a new student at school. And they had to work in groups to kind of narrow down their ideas and figure out what seemed like the most doable app for that. So that's, usually we have a brainstorming session, and we have a rule with brainstorming, which is every idea is good, no matter how crazy the idea is. Every idea goes up on the board. And so when I have a group of kids who are planning, I teach them to go to the whiteboard and just everybody start writing down ideas on the board. Everybody writes down ideas. You don't put your name on the idea because we don't want kids to own the idea, because the idea is going to change as the group kind of gets into it. And so we have them put as many of the ideas on the board as they can. And then we have any of the restrictions that we need. So it needs to use these features, or it needs to use this mission. And then we look at the ideas and we say, well, which of these ideas meet as many of the important things that we've decided, you know, we need to have. And then it becomes about the idea and not about her idea or his idea or my idea. We try to separate the personality from the idea as quickly as possible. But we want to get as many ideas in as possible. And I always listen to how kids are reacting, because we don't want kids who say, well, no, that won't work because blah, 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 or we can't do that because blah, 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 blah. Like, there's no criticism of the ideas. We get all the ideas up first, and then we take the best ones, and we don't criticize the ones that are not good ideas, because the best ideas will rise up to the top anyway. We don't have to spend time critiquing the ideas that are impractical. But if we constantly critique every idea that comes in, we're going to miss some of the great ideas that we're coming up with. So that's one of the ways that I kind of handle that. With the unplugged activity, again, going back to unplugged activities, when we start teaching concepts, here's an example of where we would ask kids to come up with sorting. So we would say, here's a number, here's a bunch of different numbers. How would you sort these numbers? How would you put these numbers in order? And we ask kids to actually try to sort them. And then once we've found strategies that kids have used, then we start to label them. Like, oh, I noticed that you took consecutive pairs and you just swapped them all the way up. That's a bubble sort. Most kids will actually start with insertion sort. So when you're sorting a bunch of numbers, you take each number and you kind of put like a sorted pile and an unsorted pile. And so we don't teach what these are first. We let the kids do the activity first, and then we look for patterns and ways to describe how they're sorting. And some kids come up with completely different ways to sort, which is interesting too. So we start with the unplugged activity first. Then we go to the guided activity where we have kids try to code a bubble sort. And for the birdhouse activity for sorting, we use a website called Sandbox, sandbox.cs50.io. There's also a website called Replit, repl.it. So Replit is another way we put up code and we'll say, here's an array of numbers, implement one of these sorts to kind of sort it, to get kids to learn how to code the different sorts, a bubble sort, insertion sort, and selection sort. But once we've done that birdhouse activity, that guided activity, we kind of go a step beyond and we kind of come up with an application of that. So the independent project, how we go beyond the birdhouse, is we go to this idea of teaching one of the sorts. So we'll say, okay, let's teach it. So kids had to do a video, and they had to use common household objects to come up with a way to teach each of these sorts. And so look at all the different ways they sorted it, like pens, they chose playing cards. You know, this kid, she actually used her family members. She put it up on TikTok. Yep. And then this one was a stop motion one that she did. So notice it's going to find the lowest number and then swap it with the next one in line. So this is a selection sort that she decided to do. But every kid did a little video to kind of show how one of these sorts would work. And then later on when I gave a quiz, I used some of the kids' videos in the quiz and said, what kind of sort is this? How would you identify that? Here's another one. But kids are so great at creating videos on their phones. You know, you can give them an assignment like this and it's fun. They're really good at creating different videos. They're like professional video makers, all of them. So I'm going to just finally wrap up. I know we're about out of time. But again, I've shown you this lesson structure going from unplugged to birdhouse to independent project. It's a way to really capture kids' attention and grab their attention. And it really goes to the heart of what we believe with computer science is this idea is we're trying to teach kids how to be autonomous, independent. We want them to live productively and safely. There's just more and more technology. It's going to keep getting added to this world as we go. How do kids need to develop a way to really understand the essential features of technology, what the beneficial and harmful effects are, and how to best communicate and work with other people using those technologies. And so hopefully this has been a helpful framework, a way to think about how to do all of these things. So, and again, I'm going to be doing a whole workshop on Saturday. We'll dive much more into depth on a lot of these things and give you a chance to start creating your own lessons. And I'll be here tomorrow as well. So, thank you.